Welcome! In this video, I will explain the purpose of this field trip, how to adapt it to different ages of children, what general materials to gather, the test supplies that you might want to order, and then finally, how to do each test. So the purpose of this field trip is for your learners to test your river or lake, stream or pond for 7 basic water quality parameters: temperature, turbidity, dissolved oxygen, biochemical oxygen demand, nitrate, pH, and phosphate. Your kids will learn how to follow testing instructions, use test tubes and chemical tabs, read number and color measurements, record data, and interpret results. They will be able to make a preliminary assessment of the health of your water by ranking their test results as excellent, good, fair, or poor using a table. Now, for younger children, they can help with filling the bucket for the turbidity test, looking at how well they can see the Secchi disc, holding or shaking tubes, reading numbers to measure the temperature, help push buttons for timing tests, and match color changes on tests to the charts. Your children will feel like they are doing real science because they are. These are actual tests done by scientists to help measure water health. Especially for your older learners, it will require them to be precise in measuring, be accurate in recording results, and to make conclusions based on the test results. So now you will be given step-by-step instructions on how to gather your general materials and test supplies before you actually go on your field trip. So let's go through the materials that you're going to need to bring on your field trip. First of all, you need to print out the water chemistry data worksheet, and you can either have it in the full form that would go on a clipboard, or you can have it like this in your nature journal. In addition, you're going to need a pencil or a non-smudge pen to do your writing of your data results. And I would suggest that at least one person has some sort of old sneakers or water shoes, because they're going to need to collect a sample in your water body that you're testing. I also prefer to have rubber gloves for those who are a little uncomfortable getting their hands too wet or muddy, as well as handling the chemicals that we have. In addition, I would suggest bringing a nice trash bag, so that people can either sit on it, or you're going to have your materials, given it might be muddy on the bank. You'll need a timer. I think it's just as easy to bring your phone to use as a timer. And I like to have a small liquid waste container, so that once I've done a test, I'm not actually taking that material and dumping it into like the stream or pond or whatever, which isn't good. If you feel more comfortable, you can have your young people have safety glasses. And then you need to have, for the turbidity test, a water container. Now, the Lamont kit comes with its own container. This is used for one of the tests where you need to have a Secchi disc, which is provided in this kit, and it's going to be attached at the bottom, and you then add water and you test turbidity. However, if you don't have this particular kit, you can also use equivalent, pretty much, a yogurt container with a white bottom. And then I have created a homemade Secchi disc that you can cut out, that you can also use and put on the bottom of your yogurt container. Also, we'll need a non-breakable thermometer. If you have the Lamont kit, it comes with a little one that you're going to need to submerge into your water body, or I suppose you could bring something like this. It would also work. In addition, you're going to want to have instructions for all of your tests. Now, the Lamont kit comes with an instruction booklet that looks like this, but also if you're doing tests one by one, you should have instructions here, like here on this particular kit testing, which is for nitrates. And that is it. And so when you're doing some of the chemical testing, you're going to need some tubes to do the tests. And so let me just show you the size and shape of the ones that I have. And of course, if you're not buying the Lamont kit, you can purchase tubes, or if you have some tubes at home that you can sort of substitute in. So in the Lamont kit, they have small glass tubes that you use for both the dissolved oxygen and biochemical oxygen demand tests. They have screw top caps. In addition, they provide you with 3 plastic tubes. Each of them have markings for both 5 mils and 10 mils. And the nitrate test, which is one of the 3, has a sleeve because you actually have to have it in the dark for, I think, 5 minutes. So if you don't have that, you could always wrap your tube in aluminum foil. Again, you can buy tubes on Amazon if you want. And then, generally speaking, the types of testing you're doing requires you to use a tab. It's one of those kind that you just break through the back. So if you want to purchase those separately, that probably is the form that you're going to want them to be in. And the Lamont kit comes with all of the test sort of color interpretation. But of course, again, if you have individual tests, you should have that as well for each test. At least 8 to 24 hours before you go on your trip, be sure to detach your Secchi disc from its backing if you're using the Lamont kit and add it at the bottom of your container and have it a little bit off center. And if you have the yogurt container instead and you don't have the Lamont kit, have your cut out Secchi disc and do the same thing using some clear tape. Next, if you happen to have the Lamont kit, what you can do is add the temperature strip that they provide on the bottom. Just detach it from the backing. And that way, when you're actually doing your water measurements, you can just stick the whole bottle in so that you don't actually have to get your hands wet or have to lose your temperature gauge. In addition, if you have really cold water, you can add the additional strip that they provide. Now that all of your materials and test supplies are gathered and prepped, where should you go? Well, remember that you want to go to a freshwater location, not saltwater. So, any stream, river, pond, or lake should work. Some things to consider are whether there is parking nearby your chosen water body, a trail or other easy way to reach the water's edge, a gentle slope or bank so that your kids can reach the water without slipping or falling, a waterway where you can bend over and collect a water sample, and a suitable gathering area where everyone can conduct the tests. And it doesn't hurt if it is a fun place to play either. When you arrive, lay out your materials on your trash bag away from the water so nothing gets wet, and it also should be the place where you plan to conduct the chemical tests. It should be a large enough space so that all of the kids that are with you can participate and watch the different color changes. For measuring the temperature, be sure that you have a place where you can submerge the thermometer at least 4 inches into the water. If you are using the Lamont kit, the temperature will appear in green on the thermometer taped to the bucket. Record the temperature on your water chemistry data sheet. To collect water, plunge your bucket into the water and rinse it out 2 or 3 times. Have the bucket facing away from you. If there's a current initially, having it face downstream when you plunge it in, you then turn it around and collect the water upstream. Now, once you have the water, for the turbidity, make sure the water in the bucket is filled to the indicated line. Then look down and compare the Secchi disc to the options on the chart or on your field trip guide worksheet. Determine the JTU's measurement and record it in your datasheet. Use the water now to perform the other tests. It's best to do your chemical tests at your site so you don't have to lug the water home, and in case you need more water at some point. But due to filming reasons, I will now be demonstrating the tests, but indoors. Now that I have my water sample, I am now going to start doing some of the tests. The first one is for dissolved oxygen. So I'm going to submerge one of the small tubes that came with my kit into the water sample until it's completely full. Then what I'm going to do is drop 2 of the dissolved oxygen tabs. So you have to look on the back if you have a kit to make sure that you're using dissolved oxygen. I have 2 of them. I'm just taking them and putting them in. And then I'm going to cap this. And I need to make sure there are no air bubbles. Then I'm going to go ahead and invert my sample for 4 minutes. Okay, now it looks like it's pretty much dissolved. I have to wait now for 5 more minutes, so I'm going to set my timer and then go ahead and wait until I see the color change. So after 5 minutes, I'm checking the dissolved oxygen, and it looks like probably it's most closely resembling the number of the 4 ppm. So the next test that you will be doing is the biochemical oxygen demand, and it has a similar start as the dissolved oxygen test, where you're submerging your tube into the water, and what you really want to do is make sure that you've got it completely submerged so that it goes up to the top, and then you add the cap. And then I'm going to go ahead and put the tube in the sleeve because it's got to sit in there at room temperature for 5 days. After 5 days, I need to take out the tube and then just repeat the same instructions that we had for the dissolved oxygen test and compare it to the same chart as the dissolved oxygen. So for the nitrate test, what you want to do is fill the test tube to the 5 milliliter line in one of the plastic tubes. It's right here with your pond water. Then what you're going to do is add 1 nitrate test tab. Just check and make sure that what you have is the nitrate. Cap it. And then what you do is open the tab and put in your tube. Once you've inverted it for 2 minutes, you then wait for 5 minutes for the red color to develop. Take a look and compare the color. In my case, it's very obvious it's 5 parts per million. For the pH test, I'm going to be measuring up to the 10 mil line and then adding the test tab. Here are the wide range pH tabs that you're going to use. I'm adding 1 to the tube. And then what I have to do is, again, cap and mix by inverting until the tablet is disintegrated. So I inverted the tube for maybe 1.5 to 2 minutes and it disintegrated. And then comparing it to the color test here on the pH, I'm going to consider it to be 7 because it's a little bit lighter than the pH of 8. So my final test is phosphate, and I'm going to again fill to the 10 mil line. This time, I'll be adding one of the phosphorus tabs and capping it. And now I go ahead and I invert it. Once the tab has disintegrated, I then wait 5 minutes in order to see the blue color develop. So after 5 minutes, I'm checking the color, and I think it looks like it's 1 part per million. Now that I'm done with my tests, I'm now going to pour all of my waste liquids into a container. If you're at the stream, you don't want to be dumping it into the stream. Once your kids have completed all of their tests and recorded the results in the data table, they are now ready to determine the quality of your water. First, have them determine the percent saturation by looking at the table in the Lamont kit on page 17. It is based on the water temperature and their dissolved oxygen results. If you don't have the kit, the same table is found under Analyzing the Results on the Umpqua Watershed website. See your field trip guide for this link. Then, go to the table that is found on page 30 of the booklet or in the same section of the Umpqua website. All of the water quality tests are ranked on a scale of 1 to 4. Fill out the column on the data worksheet to rank the water as excellent, good, fair, or poor. Now, looking at the results as a whole, what can you conclude? Is the water quality generally good, or is it impaired? And in what way?